August 2002, a Mazda engineering facility in Hiroshima, Japan. Chief Engineer Nobuhiro Yamamoto stands before a group of journalists, about to deliver news that will devastate Rotary enthusiasts worldwide. Behind him, a slideshow counts down Mazda's Rotary engine production numbers, declining, year after year, declining. A journalist asks the question everyone's dreading. Is this the end of the Rotary engine? Yamamoto's pause says everything. Mazda remains committed to Rotary technology, but the 13B REW, as currently configured, will cease production with the final RX-7 in April 2003. Will there be a successor? Another pause, longer this time. We are exploring future Rotary applications, but they will be different. What Yamamoto doesn't say, what he can't say, is the truth. The 13B REW isn't being retired because it failed. It's being killed because it succeeded too well at being exactly what Mazda could no longer afford to build, a magnificent, impractical, financially devastating engine that represented everything great and terrible about Mazda's engineering philosophy. This is the story of the 13B REW, the engine that proved Rotary technology could compete with piston engines, and why that proof nearly bankrupted Mazda, because sometimes being right doesn't matter if being right costs too much. The Rotary promise Mazda couldn't abandon. To understand why Mazda killed the 13B REW, you need to understand Mazda's unique burden. They weren't just another Japanese automaker. They were the Rotary company, the only major manufacturer who'd bet their entire performance identity on Felix Wankel's unconventional engine design. The Rotary engine, or Wankel engine, was supposed to be the future of automotive propulsion. Fewer moving parts than piston engines, smoother operation, higher power density, smaller size. In the 1960s, every major automaker was developing rotaries. NSU, GM, Toyota, even Mercedes-Benz. By 1975, they'd all quit. The problems were insurmountable: poor fuel economy, high emissions, apex seal wear, oil consumption. The Rotary engine was brilliant in theory and problematic in reality, except Mazda didn't quit. They couldn't. They'd invested too much, staked too much of their reputation on Rotary technology. In 1967, Mazda released the Cosmosport with a Rotary engine. In 1978, they released the RX-7. Each generation proved Rotaries could work in production cars. But could work didn't mean worked well. The first generation RX-7's 12A Rotary made 100 horsepower from 1.1 liters, but got 17 miles per gallon and needed apex seal replacements every 80,000 miles. The second generation 13B was better, but still thirsty, and still wore out faster than piston engines. By the late 1980s, Mazda faced a crisis. Their Rotary engines were their identity, but they were also their weakness. Competitors were building turbocharged piston engines that made more power, lasted longer, and used less fuel. The Rotary's advantages, compactness and smoothness, weren't enough to offset its disadvantages. Mazda had two choices: abandon the Rotary entirely and become just another Japanese automaker, or build one final Rotary engine so good, so advanced, that it would silence every critic and prove Rotary technology deserved to exist. They chose the latter, and in doing so, they created the 13B REW, their masterpiece, and their downfall. The engine that cost everything. The 13B REW development program started in 1989 with a directive that would have terrified any accountant: build the best Rotary engine possible, regardless of cost. Mazda's engineers knew this was their last chance. If the 13B REW failed, the Rotary was finished. If it succeeded but couldn't make money, the Rotary was still finished. They needed perfection and profitability, an almost impossible combination. So they went nuclear on the engineering. The 13B REW was a twin-turbo 1.3-liter two-rotor engine, but calling it 1.3 liters is misleading. Rotary displacement is measured differently than piston engines. A two-rotor 13B displaced 1.3 liters geometrically, but because of how Rotaries work, it breathed like a 2.6-liter piston engine. The rotors themselves were completely redesigned: lighter, stronger, better heat resistance. The apex seals, the Achilles heel of every Rotary engine, were a new three-piece design with improved materials that reduced wear by 40%. The housing was cast iron with a special coating that reduced friction and improved heat dissipation. Every combustion chamber was individually ported for optimal flow. The cooling system was over-engineered with separate coolant passages for each rotor housing. But the real innovation was the sequential twin-turbo system, two turbochargers of different sizes. The primary turbo spooled at low RPM for immediate response. At 4,500 RPM, the secondary turbo came online, and both turbos worked together for maximum power. The system was mechanically complex, vacuum-actuated, electronically controlled, with dozens of failure points, but when it worked, it was magical. The 13B REW made 255 horsepower, officially. More like 265 in reality, from 1.3 liters. That's 204 horsepower per liter in 1992. Naturally, the figure was underrated to comply with Japan's 280 horsepower gentleman's agreement, but even the official numbers were staggering for displacement. When the FD3S RX-7 launched in 1992 with the 13B REW, automotive journalists lost their minds. Car and Driver called it the best handling car sold in America. Road and Track said Mazda has built a near-perfect sports car. Motor Trend crowned it Import Car of the Year. The 13B REW had done what Mazda set out to do, prove rotary engines could compete. But there was a problem, a massive, unavoidable problem. It cost $7,800 per unit to manufacture for a 1.3-liter engine. The cost crisis nobody could solve. Here's the brutal truth about the 13B REW. Every single component cost more than a comparable piston engine part. The rotors required specialized casting and precision machining. Each rotor cost Mazda $340 to produce. A piston from a comparable 4-cylinder cost about $35. The apex seals were made from exotic materials with special coatings. Each set cost $180. Comparable piston rings cost $20. The housing required specialized iron castings with thermal coatings. Each housing cost $520. A cylinder block for a piston engine cost about $180. The sequential twin turbo system was a nightmare of complexity. The turbos themselves weren't expensive, but the control system, the wastegate actuators, the vacuum lines, the electronic controls, all of it added up to $1,200. A comparable single turbo setup on a piston engine cost about $800. Add it all up, and the 13B REW cost $7,800 to manufacture in 1992. Compare that to Honda's B18C, $4,200, Toyota's 2JZ GTE, $6,800, Nissan's SR20D ET, $3,800. The 13B REW was the most expensive engine Mazda built, and they put it in a car that sold for $32,000, a price point where they were competing against the Corvette, the Supra, and the 300ZX. Do the math. An RX-7 cost Mazda about $24,000 to manufacture. They sold it for $32,000. That's $8,000 gross profit, but nearly $8,000 of the manufacturing cost was the engine. Everything else in the car, the chassis, the interior, the electronics, combined cost less than the engine. One former Mazda accountant broke down the real numbers. We were making about $1,200 profit per RX-7 sold. That's abysmal for a $32,000 car. A Miata made us $3,500 per unit. A 626 made us $2,800. The RX-7 was a money loser that we sold for prestige. But Mazda kept building it because they believed rotary engines were their future, and because abandoning the RX-7 meant admitting the rotary experiment had failed. The reliability nightmare they couldn't fix. But cost wasn't the 13B REW's only problem. Despite being the most advanced rotary engine ever built, it still suffered from the fundamental issues that plagued every rotary. Apex seal wear. The seals that kept compression in the combustion chamber wore faster than piston rings. A well-maintained 13B REW needed apex seal replacement every 80,000 to 100,000 miles. Compare that to piston engines that routinely went 200,000 plus miles with no major internal work. Oil consumption. Rotary engines inject oil into the combustion chamber for lubrication. It's not a leak, it's by design. But customers didn't understand that. They saw oil consumption of 1 quart every 1,000 miles and assumed something was broken. Heat management. Rotaries run hot, really hot. The RX-7's cooling system was over-engineered, but owners who tracked their cars or pushed hard in summer heat would still see temperature spikes that made piston engine owners nervous. Fuel economy. The 13B REW was rated at 17 miles per gallon city, 25 miles per gallon highway. But real-world driving, especially spirited driving, yielded 12 to 15 miles per gallon. In an era when fuel economy mattered, the rotary was a gas guzzler, and turbo failures. The sequential turbo system was complex and failure-prone. The vacuum solenoids failed, the wastegate actuators stuck, the control valves leaked. Mazda dealers reported that 30% of RX-7s experienced turbo-related issues within the first 50,000 miles. Each repair was expensive. A complete apex seal replacement cost $3,000 to $4,000 in labor alone. A turbo system repair could run $2,000 to $3,000. Owners joke that RX-7 stands for Repair EXPENSE 7 days a week. Mazda knew about these issues. They'd spent millions trying to solve them. But the problems were fundamental to rotary architecture. You couldn't fix apex seal wear without redesigning the entire engine concept. You couldn't eliminate oil consumption because the design required it. The 13B REW was the best rotary engine ever built. It was also still a rotary engine, and that meant inherent compromises customers wouldn't tolerate. The sales collapse that changed everything. When the FD-RX-7 launched in 1992, Mazda projected sales of 20,000 units annually in the US market. Optimistic, but not unreasonable. The previous generation RX-7 had sold 86,000 units over 8 years. Year 1, 8,067 units sold. Not great, but launch year. Give it time. Year 2, 5,828 units, going the wrong direction. Year 3, 4,761 units. Panic time. By 1995, Mazda was selling fewer than 2,500 RX-7s annually in the US. The car that automotive journalists called near perfect was a commercial failure. Why? The reasons were complex and painful. First, price. The RX-7 started at $32,000 in 1993. By 1995, it was $37,000. That's Corvette money. And the Corvette made 300 horsepower from a V8. The RX-7 made 255 from a 1.3-liter engine that most people didn't understand. Second, practicality. The RX-7 was a two-seater with minimal trunk space and terrible fuel economy. It was a weekend car, a toy, not a daily driver for most people. The Supra and 300ZX were actually usable. The RX-7 was compromised. Third, the Rotary's reputation. By 1995, everyone knew rotary engines required more maintenance than piston engines. Enthusiasts accepted this trade-off. Normal buyers didn't. They bought Supras and 300ZXs that would last 200,000 miles with basic maintenance. And fourth, the insurance companies destroyed the RX-7's market. By 1996, insurance for an RX-7 was 40 to 50% higher than a comparable Supra. For young buyers, the target market, this made the car unaffordable. In 1997, Mazda made the decision. They would discontinue the RX-7 in the US market. Sales had collapsed to just 492 units that year. The car was unsustainable. But in Japan, the RX-7 continued. Sales were stronger. The Rotary's reputation was better. Mazda decided to keep producing the 13B REW for the Japanese market while figuring out the engine's future. That future would be decided by accountants, not engineers. The meeting that sentenced the Rotary to death. June 2000. Mazda's headquarters in Hiroshima. The company is in crisis mode, not RX-7 crisis. Company survival crisis. In the late 1990s, Mazda had overextended. They'd developed too many models, invested in too many platforms, and they'd lost money doing it. By 2000, Mazda was technically insolvent. They needed Ford, their partner and major shareholder, to bail them out. Ford's condition was simple: radical restructuring, kill unprofitable products. Streamline manufacturing, focus on volume models that made money. The RX-7 and the 13B REW were obvious targets. Mazda was producing about 3,000 RX-7s per year for the Japanese market. At $8,000 loss per vehicle, accounting for the full production cost minus actual sale price, that was $24 million in annual losses just from the RX-7. But killing the RX-7 meant more than discontinuing a car. It meant killing Mazda's rotary engine program, because the 13B REW was only used in the RX-7. No other vehicle used it. The entire engine production line existed for one low-volume sports car. James Miller, Ford's restructuring executive, made the case bluntly. Mazda cannot afford to lose $24 million per year on a vanity project. The RX-7 and the rotary engine it uses must be discontinued immediately. Mazda's engineers fought back. The rotary was Mazda's identity, their competitive advantage, the thing that made them different from Toyota and Honda. Killing it meant becoming generic. But Miller countered with financials. Mazda was losing money. They needed to cut $800 million in costs to survive. The RX-7 program, including engine development and production, accounted for $40 million annually. That's 5% of their required savings from one product line that generated minimal revenue. The debate raged for hours, engineers arguing for heritage and identity, executives arguing for survival and profitability. Finally, Mazda's president, Mark Fields, sent from Ford, made the decision. The RX-7 will be discontinued. The 13B REW will cease production. The rotary engine program will be placed on indefinite hiatus pending development of a viable business case. Translation: the rotary was dead. Not officially, but practically. Production would continue through 2002 to fulfill orders and use existing parts inventory. But no new development, no successor. The 13B REW, would die with the FDRX-7. One engineer reportedly stood up and walked out. He'd spent 15 years developing rotary engines, and in one meeting, it had all been erased. The technical advances Mazda buried. But here's what haunts rotary enthusiasts. Mazda didn't kill the 13BREW because they'd run out of ideas. They killed it because they'd run out of money. And in the process, they buried technical developments that could have solved many of the Rotary's problems. In 1999, Mazda's advanced engineering team had developed the 16X rotary engine, a direct injection rotary with redesigned port timing and improved apex seal materials. In testing, it achieved 30% better fuel economy than the 13BREW, 40% lower emissions. Apex seal life extended to 150,000 plus miles. Same power output with less displacement. The 16X solved the Rotary's biggest problems: fuel economy, emissions, reliability. It was the engine that could have kept Rotary technology viable into the 21st century. But developing it for production would cost $300 million, money Mazda didn't have, money Ford wouldn't provide for an engine that had no business case. So the 16X died in the prototype phase. The technical documents were archived, the test engines were disassembled, and Mazda's engineers were reassigned to piston engine programs. One engineer who worked on the 16X spoke about it years later. We'd solved the problems, all of them. The 16X proved Rotaries could match piston engines in every metric that mattered. But it didn't matter, because the business case didn't exist. Mazda had spent 30 years building the Rotary's reputation, and that reputation was unreliable and thirsty. We could build an engine that proved otherwise, but we couldn't change the market's perception. And without changing perception, there was no point in building it. Another buried development, the turbo compound system. Mazda had experimented with using exhaust heat to supplement rotary power, similar to systems used in diesel trucks. The prototype gained 12% fuel economy and reduced emissions by 18%. But it added cost and complexity that Mazda couldn't justify. All of this technology, this potential, buried because of one fundamental problem. Mazda couldn't afford to develop it and didn't believe they could sell it even if they did. The enthusiast market Mazda abandoned. But killing the 13BREW didn't just hurt Mazda's reputation. It devastated their relationship with enthusiasts, the people who'd kept Mazda relevant while the company struggled. In the 1990s and early 2000s, the RX-7 was the budget supercar. You couldn't afford a Ferrari or Porsche. But for $35,000, you could buy an FDRX-7 that would embarrass cars costing twice as much. Rotary enthusiasts were loyal. They accepted the maintenance. They understood the quirks. They built communities around Rotary ownership. They defended Mazda when journalists criticized fuel economy or reliability. And Mazda abandoned them, not just by discontinuing the RX-7, but by giving up on Rotary development entirely. Between 2003 and 2012, Mazda didn't sell a single Rotary-powered vehicle. 9 years. Nearly a decade where Rotary enthusiasts had nothing new to buy, nothing to look forward to, no sign that Mazda remembered or cared about the people who'd supported them. The aftermarket stepped in. Companies like Racing Beat, Mazda Spade, and RE Amemiya kept building Rotary parts. They developed the turbo upgrades Mazda wouldn't build. They created the stroker kits that Mazda never offered. They proved Rotaries could make 400, 500, 600 plus horsepower reliably. But it wasn't the same, because the aftermarket couldn't build new Rotary cars. They could only modify the ones that existed. And as FDRX-7S aged and crashed and rusted away, the pool of available cars shrank. By 2010, clean FDRX-7s were selling for more than they cost new, not because of collector status, because of scarcity. Mazda had built 68,000 FDRX-7s globally. Maybe 30,000 still existed by 2010. And each year, accidents, neglect, and time removed more from the population. Rotary enthusiasts felt betrayed. Mazda had built an engine they loved, then killed it for business reasons they understood but couldn't accept. And worst of all, Mazda didn't seem to care. The RX-8 mistake that made everything worse. In 2003, just as the FDRX-7 ended production, Mazda announced the RX-8, a new Rotary sports car with a naturally aspirated version of the 13B engine called the 13B MSP. Rotary enthusiasts were cautiously optimistic. Maybe this was the RX-7's successor. Maybe Mazda hadn't given up on Rotaries after all. Then they saw the specs. The 13B MSP made 238 horsepower, no turbo, 4 seats, front engine, rear drive, but with suicide doors and a back seat. This wasn't an RX-7 successor. This was a Rotary-powered sports sedan. And the problems? All the same. The RX-8's 13B MSP consumed oil. It needed apex seal replacements every 60,000 to 80,000 miles. It got 16 miles per gallon. It cost nearly as much as the 13BREW to manufacture, despite making less power. Worse, Mazda marketed the RX-8 to mainstream buyers who knew nothing about rotary maintenance. People bought RX-8s expecting normal car ownership. They didn't check oil, they didn't warm up the engine properly, they didn't let it cool down before shutting off. The result was catastrophic. RX-8 engines failed at alarming rates. Mazda extended the engine warranty to 100,000 miles because failure rates were so high. Each warranty engine replacement cost Mazda $4,000. With failure rates around 30%, Mazda was losing millions replacing RX-8 engines under warranty. The RX-8 destroyed what little remained of the Rotary's reputation. Before, enthusiasts accepted that Rotaries required special care. After the RX-8, everyone knew Rotaries were unreliable. Mazda discontinued the RX-8 in 2012 after selling it at a loss for 9 years, and this time, they admitted the truth. We have no immediate plans for another Rotary production vehicle. The Rotary was dead, not officially, but everyone knew. The resurrection nobody asked for. In 2023, 20 years after the FD RX-7 ended production, Mazda announced Rotary engines were returning. But not as enthusiasts hoped. The Rotary wouldn't power a sports car. It would serve as a range extender in a plug-in hybrid crossover, a generator. The Rotary engine, which once represented pure performance, reduced to charging batteries for an SUV. The announcement devastated Rotary enthusiasts. This wasn't a resurrection, it was an insult. Mazda had taken the Rotary engine and turned it into a support system for electrification. But from a business perspective, it made perfect sense. The Rotary's compact size made it ideal as a generator. And as a generator, it didn't need to be efficient under load. It just needed to run at constant RPM, charging batteries. The Rotary's efficiency problems mattered less in this application. Mazda's engineers probably believed they were keeping Rotary technology alive, finding a new purpose for it in the electric age. But to enthusiasts, it felt like watching a racehorse become a plow horse. The 13BREW represented Rotary engines at their peak, high-revving, turbocharged, powering a lightweight sports car. The range extender Rotary represented surrender, an admission that Rotaries couldn't compete as primary power plants anymore. What Mazda won't admit. Today, when journalists ask Mazda about the 13BREW and the FDRX-7, they get carefully crafted corporate responses. The FDRX-7 represented an important chapter in Mazda's history. We're proud of that heritage. Heritage, past tense, over. But talk to retired Mazda engineers, the ones who don't have to protect the company line, and you hear something different. The 13BREW was the best Rotary engine we ever built, one engineer said. It was also the one that nearly bankrupted us. We lost money on every unit. We knew we were losing money, and we kept building it anyway because we believed in Rotary engines. When Ford forced us to kill it, I understood the business reasons, but I hated it. Because we'd proven Rotaries could work. We'd solved most of the technical problems. If we'd had 5 more years and $500 million more to spend, we could have built a Rotary that matched piston engines in every way. But we didn't have 5 years or $500 million. We had debt and a survival crisis. So the Rotary died, not because it failed, but because it cost too much to succeed. Another engineer was more philosophical. The 13BREW was Mazda's Icarus moment. We flew too close to the sun. We tried to prove Rotary engines could compete with the best piston engines in the world, and we succeeded, but the cost of that success nearly destroyed us. The question nobody can answer. Here's what keeps me thinking. Was Mazda wrong to develop the 13BREW? Should they have abandoned Rotary engines in the 1980s like everyone else? Or was the 13BREW exactly what it needed to be? Proof that Rotary engines could achieve greatness, even if that greatness wasn't sustainable. The FDRX-7 with its 13BREW is now worth $50,000 to $100,000 for clean examples. That's triple its original price, adjusted for inflation. The market clearly values what Mazda built, but Mazda isn't profiting from that value. The aftermarket is. Collectors are, enthusiasts are. The people benefiting from the 13BREW's legend aren't the people who paid to create it. Drop your take in the comments. Was Mazda right to kill the 13BREW? Or should they have found a way to keep Rotary development alive? And here's the question that haunts me. If Mazda had developed the 16X direct injection Rotary, could they have saved Rotary engines? Or would it have just been more money lost on a technology the market didn't want? Because maybe that's the real tragedy of the 13BREW. Mazda proved Rotary engines could be great, but they couldn't prove Rotary engines could be profitable. And in the automotive industry, great isn't enough if it doesn't make money. The 13BREW was Mazda's masterpiece and their downfall. They built an engine so good that it proved Rotary technology deserved to exist. Then they killed it because keeping it alive would have destroyed the company. Sometimes the right business decision is the wrong enthusiast decision, and the 13BREW is the perfect example of that conflict. An engine everyone loved that nobody could afford to keep building. This is the JDM engine archive. The 13BREW died in 2003, but Rotary enthusiasts refuse to let it be forgotten. Maybe that's the engine's real legacy, proving that some things are worth loving even if they don't make business sense. Catch you next time.